Hello everyone, my name is Khurram Clark and this is my YouTube channel. Welcome to Happy Infotainment. Today I will be telling you how to construct the chemical formulae of ionic compounds. And in order to construct the formula of an ionic compound, you need to know the correct formulae and correct charges on both the cations and anions. Here are the formulae of some commonly used cations, and the charges on most of them are pretty easy to predict. For example, the charges on the group 1 elements such as lithium, sodium and potassium here, their charge is always +1. Similarly, group 2 elements like magnesium, calcium and barium here, their charges are always +2. And group 3 elements such as aluminium here in this series, they have a charge of +3 always. Their charge never changes. They always have a fixed charge whenever they are in their ionic forms. And now again, coming to the transition elements, their charges can be predicted from their names, like copper 1. Whenever copper is involved in an ionic compound, you will never hear just the term copper. It would either be copper 1 or copper 2. So that 1 or 2 represents the charge on it. If it's copper 1, the charge is +1. If copper 2, the charge is +2. Similarly, iron 2 at 2+. Iron 3, 3+. Lead 2, 2+. Lead 4, 4+. So these charges can be predicted either by their names or by looking at the periodic table. But there are some other elements or some other cations whose charges cannot be predicted by looking at the periodic table or their names, such as silver. You cannot predict the charge on silver because it is not in group 1, but it still has a charge of +1. So you have to remember that. You have to learn that. Similarly, the formula for ammonium ion, you have to learn that it's NH4 positive. Zinc, it's not in group 2 of the periodic table, but still it has a charge of +2. You have to remember that. So in order to form the formulae of ionic compounds, first you need to know, you need to learn, you need to be sure of the formulae of cations. Here are the formulae of commonly used anions, and charges on a few of them are easy to predict. For example, the monoatomic ions of group 7 elements, they all have a charge of -1, and monoatomic ions of group 6 elements, for example oxygen and sulfur, oxide and sulfide, these two have charges of -2, and monoatomic ions of group 5 elements such as nitrogen here, nitride ion, they have a charge of -3. But all the other ions, you have to learn their formula. All the anions except these group 7, group 6 and group 5 elements ions, they have to be learned. Now I can give you a few tips to remember these formulas, because I can understand that many of the students can find difficulty in learning them. Now you can learn them, you can keep a few tips in mind, such as all the ions ending with De, like here De, sulfide, De, fluoride, chloride, bromide, iodide, all the ions ending with De, they are the ions of only one single element. Most of them, not all. For example, hydroxide is, it ends with De, but it has two different elements, hydrogen and oxygen. All other ions in this table here, which end with De, they are monoatomic ions of one element. So if there is a De at the end, you have to be sure that it's the ion of a single element. But if there is a Te at the end, that means that oxygen is also present in addition to the main element of that ion. For example, here nitrate. Now nitrate, This is the ion found by the combination of nitrogen and oxygen. Nitrite, again ending with Te, nitrogen and oxygen. Sulfate, sulfur and oxygen. Sulfite, sulfur and oxygen. Carbonate, carbon and oxygen. Phosphate, phosphorus and oxygen. So you can predict in which ions oxygen will be present, but you will have to learn the number of oxygen atoms bonded to each atom of the other element. And there is also another thing that you can predict from the names. Like if you remember the formula of nitrate, nitrite will be one oxygen less than nitrate with the same charge. So difference of charges between 8 and 8. Charges are not different actually. The number of oxygen atoms are. One oxygen atom is less in ites as compared to 8s. For example, sulfate. Sulfate has 4 oxygens, sulfite has 3 oxygens. But the total charge on the ion is still the same, 2 minus. So these are the formulae of anions, and we'll use the formulae of cations and anions to construct the formulae of ionic compounds. Now that we know the formulae of cations and anions, now we can construct the formulae of ionic compounds. In order to do that, we need to implement correctly the number of positive ions which would be bonded to number of negative ions. For example, there is an ionic compound magnesium chloride. Now we already know that magnesium ion has a formula of Mg2 plus and chloride ion has a formula of Cl minus. So this is 2 plus and chloride ion, the negative ion is 1 minus. Now actually the overall formula of an ionic compound has no net charge on it. It is neutral. So we have to balance out the positive and negative charges. So this means these charges are actually not balanced here. Positive ion has a charge of 2 plus while negative ion has a charge of 1 minus. So if we take two of these negative ions, they will balance out the positive charge. And a simple way to do that is that we shift the values of charges to the bottom of the elements. There is a charge of 1 minus, so magnesium, there will be only one magnesium ion. On magnesium ion there is a charge of 2 plus, that means there will be 2 chloride ions. So the formula would be MgCl2. This is the formula of magnesium chloride. Similarly, we can take another example, sodium oxide. Formula of sodium ion is Na plus, oxide ion it's 2 minus. Now crisscross the charges, we'll get Na2O. This is the correct formula of sodium oxide. Now take another example. Magnesium oxide. Magnesium ion is Mg2 plus, oxide ion is O2 minus. Now in this case the charges are already balanced. It's a charge of 2 plus on the cation and it's a charge of 2 minus on the anion. So we do not need to crisscross, or simply we can just simplify these ions and the formula would be MgO. We do not need to put any variable with any of these elements. Now let's take another example. Calcium nitrate. Formula of calcium ion is Ca2 plus while nitrate ion is NO3 minus. Now by using the crisscross technique, we know that there will be a 1 with calcium ion and there will be a 2 with nitrate ion. But in this case, the negative ion which it has more than one different atoms. It has more than one atoms. So if we put a 2 directly here, that would represent that that 2 is only with oxygen, not with the nitrogen. But we have to involve all the elements, all the atoms in the ion. So we would put a bracket on the nitrate ion and then put a 2 here. CaNO3 whole twice. This is the correct formula of calcium nitrate. Now take another example. Ammonium sulfate. Ammonium ion is NH4 plus and sulfate ion is SO4 2 minus. Now again crisscross the charges. There would be 2 ammonium ions to balance out the charge on negative ion, so we have to put a bracket because there are more than one atoms in this ion. So ammonium ion will be NH4 whole twice and then there is SO4. We do not write 1 in the formula, so that would just be SO4. This is the formula of ammonium sulfate. Take another example. Aluminium sulfate. Now aluminium ion is Al3 plus while sulfate ion is SO4 2 minus. Now crisscross the values of charges. We'll get Al2 SO4 whole thrice. Now look at this formula very carefully. We did not put a bracket around aluminium, and that is because it had a single type of atom in it. So we do not need to put a bracket. But in case of sulfate ion, there were different atoms present. 1 sulfur atom and 4 oxygen atoms are present in 1 sulfate ion. So if we have to multiply it by 3, we need to multiply the whole ion with 3. That means we'll have to put the bracket. The overall charges are still balanced. 3 into 2 minus will be 6 minus and 2 into 3 plus will be 6 plus. So 6 minus and 6 plus, overall charge remain the same. Now take another example. Lead 4 oxide. Now on lead 4 we have a charge of Pb4 plus and on oxide it's 2 minus. Now in this case, we do not need to directly crisscross the values of charges because these charges can be simplified. We can divide both the values, both the variables by 2 and we'll get a 1 here and we'll get a 2 here. Now crisscross these variables and we'll get PbO2. Keep one thing in mind, the purpose of doing this crisscross technique is to balance out the charges, and if they can be balanced out without increasing or without considering the exact number of charges, we should balance them out, and that can be done by simplifying the charges if they are simplifiable. Now you can practice the construction of formula of ionic compounds by taking any cation from the table of cations and any anion from the table of anions. Do practice these, and if you have any questions, do let me know in the comments and also suggest me for on what topics I should make more videos. Thank you very much.